Welcome to the Deep Dive. We plunge into the most critical topics shaping our world, trying to deliver, clear, actionable insights. Today, we're diving into something truly transformative, the incredible, almost superhuman power of AI in software development. I mean, think about it. Developers are embracing these AI coding tools really fast. Something like 81% say it boosts their productivity. It really is like having a superpower, right? Writing code faster than ever before. It's accelerating everything in the digital world.
Yeah, it definitely feels like that. But here's the surprising paradox. This very superpower, while it's undeniably speeding things up, making developers feel, more productive, it's also kind of inadvertently introducing some critical cybersecurity risks.
Okay, so not all good news then.
Not entirely. We're talking about AI-generated code that, frequently contains vulnerabilities. It's creating this significant governance gap, and that gap really needs to be closed, before it becomes a much bigger problem down the line.
Right. And that's our mission today. We're taking a deep dive into exactly the cybersecurity risks of AI-generated code. We'll explore why these vulnerabilities pop up, the real challenges in actually detecting them with the tools we have now, and also the cutting-edge strategies being developed, by groups like OWASP, NIST, and leading researchers, trying to make AI coding actually secure. Our goal here is to understand how we can harness all that AI power without, compromising the very digital foundations we're trying to build.
Okay, let's really dig into this then. So on one hand, developers are widely adopting these AI coding tools. That much is clear, they see the benefits. But then you look at the data and it's a bit unsettling. Many still don't fully trust the output. I saw one survey, only 42% of developers actually trust the accuracy of the AI output in their workflows, which seems low.
It does, and despite that lack of full trust, we're seeing even proficient developers, experienced ones, copying and pasting insecure code directly into production environments. That's a bit of a head scratcher. Why do that if you don't fully trust it? What's going on there?
Well, what's truly critical here, the core insight maybe, is the sheer scale of this problem. Studies, like one by Backbench, they evaluate these large language models, or LLMs, the AI behind the tools for accuracy and security. They show that a staggering 62% of solutions produced by even the best AI models are either incorrect or contain a vulnerability.
62%? That's huge.
It is. And here's the kicker. Even among the ones that are functionally correct, about half can still be insecure.
Wow. So this isn't just about the AI getting the logic wrong sometimes. It's about it looking perfectly fine on the surface, doing the job, but actually being like a ticking time bomb underneath.
Yeah.
Which means we can't just blindly trust it for security, even when it seems to work perfectly. That's a huge takeaway.
Precisely. And this isn't just, theoretical lab research. Another empirical study, this one focused specifically on GitHub Copilot, found that a substantial 29.6%, almost a third of its generated code snippets, contain security weaknesses.
Nearly a third from a major tool like Copilot.
Exactly. And if you break it down by language, for Python it was even higher, 32.8%. For JavaScript, 24.5%. This is significant because it reflects what's happening in real-world production environments where this code gets used. And why does this happen? Well, it often happens because these LLMs are trained on billions of lines of public code, from GitHub, places like that. And unfortunately, that public code includes a lot of outdated, insecure practices.
So garbage in, garbage out, essentially.
To some extent, yes. Or maybe insecure patterns in, insecure patterns out. For instance, an AI might still recommend using an old library like jQuery, even when there are more modern, more secure alternatives available now. The models tend to favor what appeared most often in their training data, not necessarily what's best practice or most secure today. Combine that with the whole black box nature of these complex, deep learning systems. It makes it really hard to predict or even explain why certain insecure code gets generated.
Okay, so if nearly a third of this AI-generated code has security issues, what kind of flaws are we actually seeing? Are we talking about obscure, really niche bugs, or are these the more serious, common vulnerabilities that attackers already know how to exploit? The details matter here, right?
They really do, and we see a pretty diverse range. If you look at something like the OWASP Gen AI Security Project's 2025 Top 10 list, that highlights broader risks for the LLM applications themselves. Things like prompt injection, where users trick the AI, or sensitive information disclosure, where the model might accidentally leak private data. There are also supply chain vulnerabilities, data poisoning, model poisoning, bigger picture threats to the AI system.
Right, those are risks with the AI application itself.
Exactly. But then when we zoom into the actual code the AI produces, the studies find loads of specific common weakness enumerations, or CWEs. You can think of CWEs as a kind of dictionary of common software security weaknesses. It gives us a specific language to talk about these flaws.
Okay, got it. Specific types of weaknesses.
Yes. And the Copilot study, for instance, identified 38 different CWE categories. Some of the most frequent and, frankly, most severe ones include things like CWE 330. That's using insufficiently random values, which can make systems predictable, bad for security. Then there's CWE 94, which is basically code injection, allows malicious code execution, very serious. CWE 78, a classic. OS command injection lets attackers run commands on the underlying system. And CWE 95, eval injection, another way to execute untrusted code.
Those sound like really fundamental, well-known vulnerabilities, not exactly new problems.
They're not new at all. And alarmingly, 8 of these CWEs identified in the AI Guide are also on the official 2023 CWE Top 25 list of the most dangerous software weaknesses. Those 8 account for over 40% of the security issues found in the AI code in that study. So yeah, it's a concerning alignment. The AI is generating code with some of the most critical types of vulnerabilities known today.
That really puts it into perspective. It's not just minor mistakes. Could you maybe walk us through a concrete example? Like, how might an AI actually introduce one of these critical flaws into code that maybe should have been secure? A real-world kind of scenario.
Absolutely. There was one study that found a really concerning case. A base LLM generated perfectly secure code. The task was simple. Copy data from an Excel file. Okay, fine. But then they applied a technique that was supposed to make the code more secure. A technique called code guard plus any up. And the newly generated code, the supposedly more secure code, actually introduced a CWE 78 vulnerability, an OS command injection flaw.
Wait, the security technique added the vulnerability? How?
It used a function, os.system, to execute a system copy command. Now, using os.system like that is extremely dangerous because if the file paths, the names of the Excel files being copied contain malicious input like special characters or commands, it could easily lead to a command injection attack, letting an attacker run arbitrary commands on the server.
Wow, that's incredibly concerning. It's like trying to patch a small leak in your roof and accidentally knocking a whole new hole in the ceiling while you're up there.
Right.
It really makes you wonder how many developers might be unknowingly introducing these kinds of issues, maybe even thinking they're improving security.
It's a profound and, maybe counterintuitive insight. Attempts to make AI code more secure can paradoxically introduce new vulnerabilities.
So security improvements aren't always a straight line up. Sometimes it's one step forward, 2 steps back.
Exactly. This highlights a critical finding from the research. Security improvements are not monotonic. They don't always go in the right direction. AI can even introduce new vulnerabilities into previously secure code. That's a huge challenge when we're trying to build more robust systems using these tools.
This makes me ask the obvious question then. If these vulnerabilities are so common, why aren't our existing security tools consistently catching them? You know, the static analysis tools, the scanners developers already use, what are the blind spots? Why are these things slipping through?
Yeah, that's a key question. And it leads to several major challenges in actually evaluating AI-generated code security. First off, different static analysis tools you mentioned, scanners like CodeQL, Bearer, Bandit. There are others, they produce incredibly inconsistent results. Sometimes even contradictory security scores for the exact same piece of code.
Really? Like how different?
Well, CodeQL, for example, might report nearly 100% security on a snippet. Looks great, right? But then you run the same code through Bearer or Bandit, and they might show scores 25% lower. No single scanner can catch everything. They each have different strength, they look for different types of vulnerabilities, so relying on just one tool, it simply isn't enough. It makes security feel a bit like a guessing game.
It's like getting 3 different doctors to give you wildly different diagnoses for the same symptoms. Not very reassuring.
Not at all. So our traditional automated tools, they aren't a silver bullet here.
Okay, so if the conventional tools were giving us mixed signals, what about the next logical step? Using AI to catch AI's mistakes, turning the technology on itself. Or is that just wishful thinking?
It's a very natural thought, and people are definitely exploring it. LLMs have shown some promise in detecting vulnerabilities. They can find things, but they also produce a significant number of false positives.
They cry wolf too often.
Exactly. Almost 50% false positives in some cases studied. Like one LLM flagged a sensitive information leak through logging, But when someone looked at the code, it didn't even have any logging functionality in it. So this over-reporting really hinders their immediate practical use as reliable, standalone security assessment tools right now. They generate too much noise.
Okay, so AI checking AI isn't perfect either. Any other big hurdles?
Yes, a really major one is this inherent trade-off that often seems to exist between security and just basic functionality. Many of the existing techniques designed to make AI code generation more secure. They actually achieve that security at the expense of functional correctness.
No, so what do they do?
Well, they might just remove the lines of code identified as vulnerable entirely. Which sounds secure? Maybe. But often it just results in garbage code that doesn't actually do the job it was supposed to do. The original task is left incomplete. Or, as we saw with that OWASP.system example, they can even introduce new vulnerabilities while trying to fix others. And another thing, traditional evaluation benchmarks. They often focus on testing these isolated code snippets, just little pieces of code, but that fails to capture the complexity of real-world software, right? Where you have dependencies between different files, long context.
Well, it's like judging a single sentence instead of the whole paragraph or chapter. You miss the bigger picture.
Precisely. It's like evaluating a single puzzle piece instead of the whole intricate puzzle. You miss how the pieces fit together or fall apart. These benchmarks often don't account for those real-world complexities or things like common vulnerabilities and exposures, CVEs, those publicly disclosed flaws found in actual software.
Okay, so it's a really complex landscape, lots of moving parts, no easy answers yet. It sounds quite challenging. So what does this all mean for actually building more secure AI-generated code? Where do we go from here? How are experts innovating to try and overcome these deep-seated evaluation problems and these generation challenges?
We're definitely seeing multi-pronged approaches emerging. People are tackling this from different angles. On the regulatory and guidance front, you have organizations like NIST, the U.S. National Institute of Standards and Technology. They've released a new special publication, 800-217A. It's a companion to their main secure software development framework, the SSDF. And this new publication is specifically tailored for generative AI and these dual-use foundation models.
Okay, so official guidance is starting to catch up. What does it recommend?
It gives some very practical recommendations. Things like carefully handle all inputs. That includes the prompts you feed the AI and also the outputs. Log and validate everything. Use proper encoding techniques to prevent unauthorized code execution. And crucially, incorporate these new AI-specific threat types into your risk modeling. Things like data poisoning or denial of service attacks caused by adversarial prompts. It's really about building security in from the very foundation, thinking about these risks before you even generate the first line of code.
That makes sense. Robust processes, solid guidelines, clearly essential. But what about better ways to actually test the code itself, to make sure these vulnerabilities aren't hiding in there, even if you follow all the best practices of upfront?
Yeah, that's where new benchmarks come in, like one developed by Tencent called A.S.E. It stands for AI Code Generation Security Evaluation. And unlike those traditional snippet-level tests we talked about, A.S.E. focuses on repository-level scenarios.
Repository level, meaning like a whole software project.
Exactly. It simulates real-world GitHub projects, complete with actual CVEs, those known identified security flaws that have been found in those projects in the past. And it uses a multi-dimensional evaluation. It scores the AI models not just on whether the code works, but also on security, code quality, and stability over time. It aims to paint a much more complete, much more realistic picture of how these models actually perform in a complex real-world environment.
That sounds much more useful.
Yeah.
And what are they finding with this more advanced benchmark? Are we getting any closer to truly secure AI code generation?
Well, their findings so far are pretty eye-opening, frankly. Get this. No LLM they evaluated currently exceeds a 50-point score in code security on the A.S.E. benchmark, out of 100, presumably.
Less than 50. Wow.
Yeah. It highlights this clear imbalance, right? The models are getting really good at generating functional code that works, but they still struggle significantly with robust security. And interestingly, they found that slow-thinking reasoning paradigms—
You mean where the AI takes more steps, tries to reason more deeply?
Exactly. Those often underperform their fast-thinking counterparts when it comes to security fixes. It suggests that just making the AI think harder doesn't always translate to better, more secure code. Sometimes, maybe, simpler is safer.
That's another fascinating counterintuitive point. We always assume more thought equals more secure, but maybe sometimes that extra reasoning leads it down an insecure path. A real lesson there for how we train these things.
It is. But there's also some promising news on the model front. Open source models are proving highly competitive. For instance, one model, Qwen3 235B A22B Instruct, actually achieved the highest security score in their tests, even outperforming some well-known proprietary models.
Okay, so the open source community is keeping pace, maybe even leading in some areas of security focus. That's good to hear. But it also sounds like beyond testing, the industry is using AI to fight fire with fire, right? Using AI itself to make AI-generated code more secure, not just generated in the first place.
Exactly. And this is where some truly innovative AI-driven strategies are coming into play. AppSec Engineer outlined several interesting ones. One is called Coder Reviewer Re-ranking. It's basically a dual model framework that mimics how humans do code reviews. You have one AI that generates the code, and another autonomous AI that acts as a reviewer evaluating, critiquing the generated solution. And this approach, they found, can cut down on poor or insecure solutions by a remarkable 62%.
Okay, AI reviewing AI. That makes intuitive sense. What else?
Another strategy is modular code generation through chain of revisions. Here, the AI breaks down the coding problem into smaller, more manageable, reusable submodules, and then it refines these modules iteratively, kind of like an expert human developer would, building complexity step by step. This approach can apparently reduce errors by about 41% and also significantly boost code reuse, which is generally good for maintainability and security.
Breaking it down, refining it, like careful engineering.
Precisely. And perhaps the most intriguing one is something called dual critic agents. Here, you have two autonomous AI critics working together. One is focused purely on safety and security. The other is focused on helpfulness and functionality. And these two critics engage in a kind of internal dialogue, constantly debating and refining the code to satisfy both security and functionality goals simultaneously.
Wow, like an internal devil's advocate, but for security.
Kind of. And this method has shown the potential to lower vulnerabilities by a staggering 89% without sacrificing the quality or functionality of the code. That's a huge potential leap forward. It's moving beyond just generating code to having AI intelligently self-correct its own security flaws.
What a deep dive this has been. We've really covered a lot of ground. We've seen that while AI offers these immense benefits to software developers, accelerating creation, boosting productivity, no doubt about that, it also introduces some really significant cybersecurity challenges, serious ones. From those prevalent vulnerabilities like OS command injection to the complexities of just evaluating security with inconsistent tools and those frustrating trade-offs with functionality. The landscape is, well, it's both daunting and clearly ripe for innovation.
Absolutely. And this raises a really important question, I think, for you, the listener. As AI becomes an even more integral part, maybe the central part, of creating our digital world, how do you ensure that the convenience it offers doesn't inadvertently build a less secure future?
That's the critical question, isn't it?
It is. And the answer, at least for now, seems to lie in continuous security analysis. Vigilance. It needs to be a combination, right? Using the best advanced automated tools we can develop, but also maintaining vigilant human review and oversight. That human element is still critical. Organizations absolutely need to implement robust governance policies around AI use and development. And developers themselves, well, they need to cultivate greater security awareness and skills. Really embrace those secure by design principles right from the beginning of any project involving AI-generated code.
Yeah, it's clear the responsibility doesn't just rest with the AI models themselves or the companies building them. It rests with every single one of us who interacts with, uses, and deploys this powerful technology. Remember, AI is ultimately a tool. And like any powerful tool, its safety and security depend fundamentally on the skill, the awareness, and the care of the hands that wield it. Definitely something to ponder as you navigate the ever-evolving world of AI.